We are on to the last section of your packets for this little mini unit here. We're doing absolute value. So guys, I'm on absolute value equation note B in your packets. So if you turn to that page, just follow along with these notes. This uses a lot of what you've learned with solving equations, and you guys saw that you still use that with solving inequalities, and now I'm going to show you that we use it with absolute values too. So first off, what is absolute value? Absolute value, we use these symbols here, these two vertical lines, and it means a distance from zero. So this equation here, for example, number 1 says the absolute value of b is equal to 9. So really what that means is b, the distance it is from 0, is equal to 9. So the question is, well, what values of b make this equation true? So think, what is 9 away from 0? And we actually have two answers, which is why there's two boxes here. Positive 9, but also negative 9, right? Both of those numbers are 9 away from 0, just on going in opposite directions, right? And that's what you need to think of as we solve these absolute value equations, okay? The distance from 0 has two possibilities, because you're either on the positive side of 0 or on the negative side of 0, that same distance away. For example, number 2 says the absolute value of k plus 6 is equal to 10. So we're going to start off doing, what we normally do. Subtract 6 from both sides, and we're left with the absolute value of k is equal to 4. So same deal, k's distance from 0 is 4. Well, there's two possibilities for that. K can either equal positive 4, or k could equal negative 4, right? So my goal here is, as I'm solving these absolute value equations, to get the absolute value bars by themselves on one side of the equal sign, and then I can see what my two answers should be. And you see what I mean here with example number 3. For example number 3, k plus 6, now the entire thing is in those absolute value bars, so that entire expression, k plus 6, is 10 away from 0, which means k plus 6 could equal positive 10, or k plus 6 is equal to negative 10, right? But both of those are 10 away from 0. So I'm going to solve both equations. When I subtract 6 from both sides, I get k equals 4. Kind of like how we got that as one of our answers for up above. But when I solve the other equation and I subtract 6 from both sides, I'm left with k equals negative 16. Okay? So moving on, it's the same deal with example number 4. The entire expression of 8 minus 2n is 2 away from 0, right? So that means it could be equal to positive 2 when I do all of that expression, or it could be equal to negative 2 when I figure out what that expression is. So I've got two equations to solve. 8 minus 2n is equal to positive 2, but it could be that 8 minus 2n is equal to negative 2. Okay? Now notice, for example number 3 and example number 4, when I split that equation down, I'm getting rid of those absolute value bars, right? When I'm writing out when it's equal to the positive possible answer or the negative possible answer, because those absolute value, that's just a distance, it could either be on one side of 0 or on the other side of 0, I'm getting rid of those absolute value bars. So here, I'm going to subtract 8 from both sides, and I'm left with negative 2n equals negative 6, because 2 minus 8 is negative 6. And then I divide by negative 2 on both sides. A negative divided by a negative is a positive. So n could be positive 3. And then when I solve the other equation, I start the same way. And in fact, my steps to solve are exactly the same. It's just I'm going to get a different answer because it's a different number after the equal sign, right? I'm left with negative 2n. This time equals negative 10 because negative 2 minus 8 more puts me at negative 10. And I'm going to divide both sides by negative 2. Again, a negative divided by a negative is a positive. 10 divided by 2 is 5. So now my two possible answers for n are 3, positive 3, or positive 5, right? For example number 5, it says the absolute value of 3r plus 6 is equal to 0. So what's that saying? That's saying that expression of 3r plus 6 is 0 away from 0. There's only one possible answer. There's only one number that is 0 away from 0, and that's 0. So I don't actually need to write out two equations here. I just need to write out one. So I've got 3r plus 6 equals 0. And that's it. Okay? I don't have to set up another equation because there's only one number that's 0 away from 0, and it's 0. So I'm going to solve this one, subtract 6 from both sides, and we're left with 3r equals negative 6. And then divide both sides by 3. And we're left with r equals negative 2. So again, absolute value, that's just a distance from 0. Now when you guys turn to the next page, example number 6 here, it says the absolute value of 4r plus 3. So that expression, the absolute value of that, the distance from 0 is negative 1. You can't have a negative distance. You cannot have a negative distance, right? I always like to think of, Michael Phelps. Even when he does backstroke and he's swimming backwards, he's still doing a positive distance, right? There is no negative distance. So if your absolute value bars are set equal to a negative number, that's not possible. That's not possible. So we're going to go ahead and put no solution for this one because you can't have a negative distance. Okay. It says here, do not distribute. So you guys know we have two options when a number is written beside parentheses. And absolute value bars are treated like parentheses as far as order of operations are concerned. Okay. So they're a grouping symbol. So we can distribute, right, when a number is written beside parentheses, or we can divide both sides by that number. So we have some examples here that are going to show you what that means, what that looks like. But you don't want to distribute when it's absolute value bars. Instead, you want to do our second option, which is divide. So here it says, do not break it out into the two equations until the absolute value is by itself on one side of the equation. So we want to get the equation down so that it's just the absolute value bars on one side. Then we split the equation. Okay. It says try these more complex problems. Make sure you have two answers. So let's do it. For example number 7, I've got the absolute value of 9 plus 3n. That is being divided by 9, and it's set equal to 5. So I'm going to do the opposite of that, divide by 9. I got to get rid of that first. I'm going to multiply both sides by 9, and what happens when I do that is these 9s cancel. So now I'm left with the absolute value of 9 plus 3n is equal to 45. From here, because now my absolute value bars are by themselves on one side of the equation, I'm going to split up my equation and get rid of those absolute value bars because the expression 9 plus 3n is 45 away from 0. That means it could be at positive 45 or it could be at negative 45. So 9 plus 3n equals positive 45, and 9 plus 3n equals negative 45 are my two equations that I'm going to solve. And my steps are going to be the same. I'm going to subtract 9 from both sides to start. I've got 3n, 45 minus 9 is 36. And then over here, subtract 9 from both sides. You don't have to solve them both at the same time. I'm just doing it with this one. I get 3n equals negative 54. Okay. I now just divide both sides by 3. So 36 divided by 3 gives me my first answer of 12. And then negative 54 divided by 3 is negative 18. So I've got the n is positive 12 or n is negative 18. For example number 8, same thing. Okay, the absolute value bars are not by themselves, so I'm going to get rid of the plus 1. I'm going to subtract 1 from both sides first, and that's going to leave me with absolute value of 7 minus 3x is equal to 10. Now that the absolute value bars are by themselves, that expression is 10 away from 0. So it could be at positive 10 and it could be at negative 10. So I'm going to set up my two equations from there. I didn't draw this before, but I'll draw it this time. So I've got 7 minus 3x equals positive 10, and 7 minus 3x equals negative 10. All right, from here, same steps to solve both of these. I'm going to start by subtracting 7 from both sides. That leaves me with negative 3x equals 3. Subtract 7 from both sides, and that leaves me on this equation with negative 3x equals negative 17. And then I'm going to divide both sides by negative 3. A positive divided by a negative is a negative, so I've got x equals negative 1 as one of my answers. But then the other one, I've got, when I divide by negative 3, a negative divided by a negative, so negative 17 divided by negative 3 is a positive, and 3 goes into 17 5 times with 2 left over. So 5 2/3. Okay. All right, for this last one, we are not going to distribute like we said before. Instead, I'm going to divide both sides by what's out in front of the absolute value bars. And it's a good thing I'm doing that, because as you guys see, it says right here that the absolute value, which is on the left, is equal to a negative number. Well, we talked about that with example number 6. You can't have it equal a negative distance, right? There is no such thing as a negative distance. But when I divide both sides by negative 8, look what happens here. Negative 120 divided by negative 8 equals positive 15. So now my equation is, these negative 8's cancel. My equation is the absolute value of negative 5x plus 5 is equal to 15. And from here, I'm going to set up my two equations, right? The absolute value bars are by themselves. So I write my two equations without the absolute value bars. It's either negative 5x plus 5 equals positive 15, or negative 5x plus 5 equals negative 15. Okay, the absolute value bars are gone. These are just normal equations now. So I'm going to start the same way on both of them. I'm going to start by subtracting 5 from both sides. And that gives me negative 5x equals 10 for the first equation. And then negative 5x equals negative 20 for the second equation. And then my last step is just divide both sides by negative 5. And when I do that, I get x equals, let's see, positive 10 divided by negative 5 is negative 2. And then divide both sides by negative 5 over here. This time, a negative divided, whoa! Let's go back to that. My fault. I hit the page button. A negative divided by a negative is a positive. So I've got x equals negative 2, or x equals 4. All right, you guys see your practice there on the next page. Give it your best shot. If you have any questions, make sure you ask your teacher.